Hello, everyone. Welcome to Algorithms in Swift. My name is Kevin Tarr, and today is officially day 11 of Algorithms in Swift. I can no longer use my hands as visual optics to describe the day, okay? So you got to bear with my voice, okay? Um, Today, we're going to be discussing yesterday's problem, actually, okay? So I've come up with another solution to yesterday's problem. Yesterday's solution. There's nothing wrong with yesterday's solution. Actually, it was a very clean, clever, and efficient one-liner that solves the entire problem. But for rotation, I think it's important for us to discuss ranges and discuss string ranges and array ranges. So I think that also goes in hand with understanding rotations. Okay, and I'm also going, guys. I'm also as a part two to this a treat. I'm also going to give you guys the one line solution to the Pangram problem that I solved in the first video of the series. If you remember the 26 letter alphabet detection problem we solved in the first video, I'm going to give you guys the best and most optimal solution to solving this. Think about sets, and your mind should do the rest to get there before I get there. Okay. Well, let's get started. Let's begin. Okay, guys, let's jump straight into our problem here. Okay. For those of you who watched yesterday, you understand what we're already doing. If not, you can read right here. You can watch the video from yesterday. Okay. I'm going to call this function called rotated. I'm going to create a function called rotated. String one, string two. I'm going to return a boolean. I'm going to write a guard statement here to protect us. So I'm going to automatically find out if both strings are equal to each other in terms of length. And we're also going to check to see if the count of our strings are greater than 1. If either of these are false, we're just going to exit the function immediately. If not, we're going to proceed with our function, okay? Then we're going to create arrays of these strings. First word array. I want to call this array string 1. Let rotated array, rotated word array equal string 2. And then we're going to let count equal the count of the array, of the first word array. And then we're going to do a for loop, fast enumeration, because I love fast enumeration. And first word array got enumerated. If rotated the first is equal to letter, then we're going to check to see if first word array to index count is equal to rotated word array 0 to count minus index. Okay. If that's true, we're going to write one more if statement. The first word array 0 to index is equal to rotated word array count minus index to count to index, I believe. Okay. And if this is true, then we're going to return true. And this is false, we're going to return false. Okay. 0 to index. Okay, let's see. Okay. I know I did something buggy here. Okay. That's a dub moment. All right. So this is true. What you can see is happening here is here's a clear explanation right here. Um, when we find a letter, so we're constantly going through the first string and finding and seeing if we have the first letter of the second string in this first string. So we go past K, no, E, no, V, we find it. Okay, so we say, okay, if first if this index up into the length of the string, the remainder of the string is equal to this zero, the zeroth index of this string up into the index, the numbered index of the letter that is currently on, which will be 2, because that's what we found the V at 2. Then also check if the first word array up into the index V 0 to 2 would be KE is equal to the count minus index. The count of Kevin, the number of letters is 5, minus index is 2 would be 3. So up until so 3, starting with 3, right here, up into the remaining count, which would be 5. So up until, so not including 5. So it'd be 3 and 4 if these two are equal. And if they're equal, and these three are equal, then we have a true rotation. That's just plain with ranges, okay? So you can test this one out on your own Xcode software and see if it works. But I guarantee you it will impress your interviewer, okay? So now I'm going to give you also the one-liner, the fancy one-liner for the Pangram problem, okay? So this is my favorite, I think the best solution to this problem. You can solve this entire problem in one fancy line of code, okay? So what you could use is my favorite collection type, which is a set, and stuff the entire string into a set. Lowercase it, then filter the entire string, or entire set, ask if each element is greater than A, greater than or equal to A, and less than or equal to Z. If it is, check the count and see if it's equal to 26. If it's equal to 26, that means we have every single letter of the alphabet. Why is that? Because we know that sets eliminate all duplicates. So we're only dealing with unique letters, and we're only dealing with letters because we're comparing between A and Z directly, okay? So let's run our problem. Let's do a pangram. The quick brown fox jumps over the lazy dog. Or jumps over the lazy dog. Okay, this should return true. Yep, instantly. And sets are extremely fast. They're constant. They run on constant time. So they're extraordinarily fast. No matter how many elements you have, they run at the same constant time, okay? So you see jumps return true, jump return false. Okay, if you guys didn't see it, I'm going to do it again. Jumps returns true with the S. This has every letter of the alphabet. Jumped returns false. Boom. One line of code. Okay. So, and if you guys don't remember this problem, just check out the first video of the series. I went over this problem. I gave you guys 2 solutions to this. This is the third solution. This is my favorite solution. And also, guys, let me know what you think of this past solution. I think both problems are pretty good testing skills, and I think that in interviews you will definitely come across this problem. So make sure you're sharp on understanding not only the solution, but understanding the explanation and the how-to as to what you're doing and why you're doing it, okay? Thank you guys for watching. Hope you guys have a great night. Adios. Bye.